Let's go ahead and bring back a familiar term that you guys have heard before, homologous chromosomes, and really what's going on with those homologous chromosomes as far as genetics is concerned. Get my pointer here. So here I have homologous chromosomes. I can assume that this top one is maternal, came from the mom, and down here, this homologous chromosome came from the father. That's the paternal homologous chromosomes. They're partners. Remember that our chromosomes occur in pairs. These are termed homologous chromosomes, but very much diploid organisms. There's that pinched area where the centromere is going to be located. I can see that it's in a similar spot to its partner. But what I really want you guys to see are these highlighted bands here, different colors. Here I have gray, here I have yellow, here I have green. What these are showing me are gene locations. The word that we use for that is loci. All across the chromosome. So at this part of the chromosome, I'm going to have a gene that's going to be associated with that genetic material, that nucleic acid. It looks like that gene encodes for this allele, P. I don't know what it is. Let's call it hair color. And so that there's an uppercase P allele for that hair color. And then down here, there's also an uppercase P allele for this hair color example that I'm giving you guys, that gene. This is going to be, again, a homozygous individual because they have this same allele in those homologous chromosomes. In fact, they're homozygous for the dominant allele. Here's another gene encoding for something, some protein, lowercase a at one chromosome and also lowercase a at another chromosome. That individual is going to be homozygous as well, but I would actually say that that individual is homozygous recessive for that gene. So there's different versions of homozygous. You could either be homozygous dominant or homozygous recessive. Here is example, our last our last gene showing a dominant allele and then showing a recessive allele. So because I have two different alleles now, that individual is heterozygous, showing one dominant, one recessive. Keep in mind that that dominant allele will mask the recessive allele for whatever phenotype that it's encoding for.